Okay, so today we are going to cover the last section of chapter 6. This will be the last section that's on your test, which is Friday. And we're going to learn to use the proportionality theorems. And there's going to be several in this lesson. So the first one is called the triangle proportionality theorem. So what this theorem states is if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So we have this line that's parallel to this one, and it's going to divide the two sides proportionally. So for example, in the proportion that was given, we could see that this top right piece over the bottom right piece is proportional to the left top over the left bottom. Now, I'm going to show you several other ways that you could set up proportions. This isn't the only way to do it. Okay, so that's one way. You could have also done the two top pieces. So let's say you did AB over AE. So this time we're going to take this top over this top, and then underneath we'll have the two, then the next fraction will say BC over ED. So the two tops in the same fraction and the two bottoms. Notice when I do the cross products here, I'm multiplying A times B, AB times ED, and that's what I am doing here. And then the same thing on this cross product, BC times AE, and then same here. Now, we could have also set it up as AE over AB. So, same thing that I did here, I'm now going to flip the fraction and then put ED over BC. Now, when we had the two parallel lines, the reason why we can set up all these proportions is what we've done by stating that we have the two parallel lines and we can say that the sides are proportion. What we've done is we've made the two triangles similar. And we know that when we have two similar triangles, the sides are proportional. So here, the two triangles they're referring to is this top one here and then the entire one. And remember, when you have two pairs of parallel sides, we know that this corresponding angle here would be congruent to the bottom angle in the bottom. And then we also had the top A that was the reflexive, it was the same in both. So we could show that these are similar triangles by our AA postulate. And as soon as we know the triangles are similar, that's why we can set up all these proportions. Does that make sense? Okay, let's look at the next slide, which is the converse of the triangle proportionality theorem. We're switching the if and the then. So we've switched the if and the then, and now it's the converse. So now instead of first saying that the lines are parallel and then the sides are proportional, now we're saying that if the sides are proportional, then these two sides are parallel. So that's the converse. Now, there's not going to be a proof on the test, so you're not going to have to come up with this as a reason in your proof, but you're going to need to know how to set up your proportions. And we're going to see that on the next slide, where we're going to be finding missing side lengths. All right, next one. We're going to apply this. So again, we've got our parallel sides, and we could show that the triangles are similar. So because this little triangle is similar to this big triangle, I know my sides are proportional. So the first proportion that they're writing here is they're doing CD over DA. So they're doing the bottom over the top, right side. So what would be my other fraction that I'm going to fill in here that it's proportional to? Michael?
CE over EB.
Good. Okay, we're taking the left pieces. So this CE over this ED. That could be your proportion, yes.
So before you do this, you have to prove that they're similar?
No, you could just say that you can set up the proportion by that triangle proportionality theorem. I'm just saying that because the lines are parallel, we know we have corresponding angles plus the reflexive C. So this is why we can set up these proportions. All right, let's look at part B here. It says, and I'm going to fill in the numbers here. Let me erase this stuff. All right, so for part B, it's telling us that CD is 3, DA is 6, and DE is 3.5. Now, let me just redraw these over here so you can see. So 3.5, 3, and then I know that this whole side here of this big one is 6 plus 3, which is 9. It wants me to find the value of AB. I can put in E, D, C. Okay. What would be, yes? For A? Yeah. EB? Oh, yes, thank you. That should be a B. Okay, so that is EB. Good catch. Okay, let's go ahead and set up the proportion to find the value of AB. What would be a proportion I could set up? Michael?
3 over 90.
Good.
Equals 3.5 over X.
Perfect. Okay, cross multiply and divide. So 3 times X, 3.5 times 9 is 31.5. Divide by 3, and my value of X is 10.5. Good on that? Let's look at part C. Let me redraw. So I've got the little one and the big one. E, A, C, E, D, C. So it's telling me that CB is 12. So this whole thing is 12. And then it says EB is 8. Let's put this in red. And this one's 8. And then CD is 6. So CD right here is 6. And okay, so what can we do here? What would be the proportion to find DA? Did I do something wrong here? Let's see. I need to show like maybe the breaks here. So this is D, and then right here is E. And I know from here to here is 8. Okay, Jason, what are we going to do?
I was going to say let's subtract 8 from 12 to find the length of CD.
Good. Okay, we can see that it's 4. Okay, so then I can put the 4 here. And now what do you want to do?
So now the proportion would be like
4 to 12.
plus 2/3.
I'm sorry?
Which simplifies to 1/3.
Okay, 1/3. Okay.
And this proportion is 1/3 equals 6 over X.
All right, and then what's that going to give us? Okay. We're looking for DA though. We're looking for this piece. So when we set up this whole thing, this X is really going to be AC. Follow that? But what we wanted was DA. So we can do this, and we'll get this X, or AC, is 18. Okay? In our picture, what did we know? We knew that CD was 6, so to find AD, we could do 18 minus 6. And then the length of AD is 12. Okay? So that's one way we could do it. Let's find another way. All right, what if we did, like he said, subtract and get this 4? So 12 minus 8, and that's how we can get the 4. So then what if we did 4 to 6 and 8 over x? So what I'm doing here is I'm taking these two and matching it with these two. Cross multiply and divide. 48, divide by 4, and then x gives us 12. Another way, yes, Michael.
Why is it 8?
Okay, because let me go ahead and erase. Let's see. I'm going to need to redraw because I can't erase. Okay, so I have the original triangle, B, A, C, E, D. Okay, so for this one, it said that CB was 12, EB was 8. So we already established that we could do 12 minus 8 and find the value of CE to be 4. We were also given that CD was 6. So what we're doing here is we're trying to find AD. So the proportion I used was this left bottom over the right bottom, and then the left top over the right bottom. So 4 over 6, this row, equals this row. That's where the 8 came in.
Is that the triangle something?
The triangle proportionality theorem.
That's it.
Yes. Now, you could have set it up another way. You could have also, if you wanted to use the 12 and not find the 4, you could have also said 8 over, so this 8 over the total is equal to this x over the total, which is x plus 6. You can do it that way also. So if we cross multiply, move the 8, 4x equals 48, divide by 4, and again, x equals 12, which was AD. So there's more than one way to set up your proportions. Just make sure, sometimes it's easier if you separate the picture and draw your own two little triangles, one little one, one big one. Pretty good on this example. All right, let's look at another one. Anybody still need this slide? Okay. Theorem 6.6. Again, you don't need to know that it's called Theorem 6.6. Know what the theorem states. And what the theorem states is if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So here are my 3 parallel lines. Here are my 2 transversals. And it's going to make all these little sections here that will be proportional. So let's go ahead and see how they set this one up. So they took the BC, the right top over the right bottom, and they set it equal to the left top over the left bottom. Now, you could also say that the left top over the right top is equal to the left bottom over the right bottom. So this would be another way you could set up your proportion. You could even go bottom to top. You could say this bottom over this top, so EF over AF equals this bottom, so CD or DC over here. So notice in the original, these were both from the top, these were both from the bottom. So different variations of the same thing. Notice each time the cross products are the same 4 letters. Okay, example 2. Now we're going to apply that theorem. So I'm going to go ahead and add in my numbers. For letter A, I'll do it in the red. So A is 2, B is 3, C is 5. Remember, when we have 3 parallel lines and it intersects 2 transversals, we can set up proportions to find the missing letter. So I could either do top left over bottom left, and then top right over bottom right. Cross multiply, divide. Remember, for side measurements of these segments, I want it as a mixed number or a decimal. So either 7 1/2 as a mixed number or 7.5. Now, we could have also set it up as maybe this top 5 over the top 2. And then put the D over the 3. Again, you're still getting the same thing. So you could have set it up that way. You could have either gone bottom over top and then bottom over top. Cross multiply and divide. So all different variations of the same problem. You know, we could even take this one and flipped it. Instead said, I'm going to do the 2 on the top, 5 on the bottom, and then 3, and then the D. So all of these are all different ways to do part A. Part B, my A is 4, my B is 8, C is still 5, but now instead of asking for just D, it wants C plus D. Now, I can solve it the same way I just did, get D, and then just remember to go back and add it to C. So, for example, I could do top left over bottom left, top right over bottom right. Cross multiply, find out the value of D is 10, but remember they didn't want just D, they wanted C, which was 5, D that I just found to be 10, add it, and it's 15. And again, you could have done any of the other variations of the proportions and still get the same thing. If you wanted to go right to the answer, what you could have also done is 4 over 12, because the whole thing was 12, because that's what it was asking for. So 4 over 12 is equal to 5 over, and we could say it's x. We could say x equals C plus D. Cross multiply and divide, get 4x equals 60, divide by 4, x is 15. So if you did it this way, it went right into the answer and you didn't have to add it. Because you said, I'm going to have my x to be c plus d. One more theorem. So again, for Friday's test, be able to apply these to find the missing values, to find the missing side lengths. Okay, last theorem, theorem 6.7. Again, you don't need to memorize. That's theorem 6.7 says this. Know what the theorem is and how to apply it. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So what this is saying is, here's the ray coming through here. It's splitting it into an AD and a BD. And then it's saying that this side AD is proportional to the other sides of it. So sort of think of, you got a triangle here on top, triangle here on the bottom. So this BD and this CD go together, and this AC and AD go together. Now in their proportion, the first fraction was the split sides. But the one that it matches with, this is the side that AD came around. It's the other side of its triangle. And then the CB was the other side of the DB. And I'll show you a few more proportions that you could also have set up. So you could have also said AD matching with the side of the triangle that it's in. So the green triangle. Then the DB, the one that the ray created, with its BC. You could have also said CA and AD, and CB and DB. So these are the two pieces that were created, and this is coming around the other side of it. Does that make sense? Now we're going to apply this theorem. And now we will apply it with example 3. Can someone give me a proportion we could come up with to find the value of x? Michael?
12 over 24, or half, equals 10. I don't know what's put on there.
Okay, so let's just put in another letter there. Let's put y in there. Does that help you?
Yeah.
Okay, so we'll put y here. Okay, now what?
And then solve it.
Okay.
Get y equals 20.
Okay,
And then add that to 10.
beautiful. So this is something you can do. You can come up with your own letter and find just the little piece first. And then 10 plus 20, the value of x is 30. Now, another way you could have gone about solving this is you could have, let's just do this still with the y. You could have also done 12 over 10 equals 24 over y. Now, you can do like Michael did, and you can simplify this and make this 6 over 5. So you're not, multiplying really big numbers. So then you would get 6y equals 24 times 5, 120. Again, divide and get 20 again. Now, the other way is you could have realized, instead of introducing a variable y, you could have said that this little piece, if you want to keep it in terms of the same letters that are there, this little piece, bless you, is x minus 10. So the whole thing minus 10. Now, I liked putting in the y. It made it a little bit easier, and then going back and adding your answer was easy. But if you did it by making this instead x minus 10, then you could have set up 24 with the x minus 10. So this side going around and grabbing this, and then the 12 going around with the 10. And we could cross multiply and divide. Again, if you wanted to simplify the 12 over 10 to 6/5 first, and then multiply what's left, here we would get 6x minus 60 equals 120. Add that, and then 6x equals 180, divide by 6, and then that x was what we were looking for, and it's 30. So multiple ways to solve the same problem. So know when you're taking this test, there'll be, everybody might set up a different proportion. I'll be looking to see if your final answer and all your work comes up with the correct answer. So this concludes 6-5. This is the last that we're learning. Again, we will spend the next 2 days. Tomorrow we'll go over this homework first, and then we will start reviewing. Now, let's take a look at the homework, because in the homework, I'm going to have you not complete 3 of the questions, because I'm not going to ask you to pull out a ruler and construct these things. So if you open up your practice B, let's go ahead and take a look at it, and I'm going to tell you which ones you can cross off.